Hello everybody, we have another quick lesson on 1D kinematics. This is a problem. So I'll read the problem out. A space vehicle accelerates uniformly from 65 meters per second at t equals 0 to 162 meters per second at t equals 10 seconds. How far did it move between t equals 2 seconds and t equals 6 seconds? Now the first thing you should do when you see a problem like this is that you should highlight or make note of the most important information in the given problem. So you can see that it says accelerates uniformly. This states that basically the acceleration is going to be the same throughout the entire problem. So that's a hint that you really need to catch when you read a problem like this. It says it goes from 65 meters per second. That would mean the initial velocity when it at time equals 0 is going to be 65 meters per second. Then we hear 162 meters per second at t equals 10 seconds. So this would be the final velocity in this instance at 10 seconds. Because after 10 seconds, I suppose, is not important. And then the question that we need to focus on, how far did it move between t equals 2 seconds and t equals 6 seconds? So now that we have that information, we can begin to solve the problem. For one, let's just write down what I just stated. So a is going to be some constant number throughout the problem, meters per second squared. That's the unit for acceleration. The initial velocity, which can be written in several ways, is 65 meters per second. And the final velocity, which also can be written in several ways, is going to be equal to 162 meters per second. And we have from t equals 0 to t is equal to 10. So it's going to look a little bit like this if we do a quick little diagram. So this is at t equals 0. Let's say this is t equals 2. Basically, as it's accelerating, that means the velocity is going to continually increase, meaning that in each consecutive second, the ship is going to go further than it went in the previous second because it's going to be going faster. So let's just say 6 is over here, and then let's make this even longer and say that t equals 10 is over here. It's not exactly up to scale, but it gets to the point I'm trying to express. But what we want to find is this. These two distances here. But to find that, we're going to need to find the entire distance from t equals 0 to t equals 10, because basically you can think about it like this. If we find the acceleration with the information that we have, because we only know that this is at this point, and we know that this is at this point. So what we want to find is a way to find the distance at this point. But none of these equations fit, because if we look at it quickly, the final velocity we don't have at t equals 6, so, and we don't have the acceleration there, so we cannot solve the first one here. And the second one, we don't have the final, and we don't have the final distance. I mean, the change in distance, so we can't solve that either. And then if we look at the third one, I don't know, it just doesn't work. So the best method to do is find the acceleration, because acceleration is uniform throughout the entire process, the entire spaceship travel. So if we find it by utilizing the knowledge that we have here, then we'll be able to find this right here. So let's do that very quickly. If we look at the first equation, this fits perfectly because we have the final velocity, which is equal to 162 meters per second. We have the initial velocity, 65 meters per second, and we have the time, which is 10 seconds. So we'll take it, v equals v0 plus at. I'm just moving v0 onto the other side. And now I'm just going to divide both sides by t. So v minus v0 divided by t is equal to a. And now if we plug that in, we have 162 minus 65 divided by 10 is equal to, this is about 9.7 meters per second squared. So that would be the acceleration. Okay, so that will be step 1. Now we want to find, to continue on, we want to now find this right here. So at time equals 6, how far did the spaceship go? That is the question. Now that we know acceleration, let's use this one because we have acceleration to use right there. So change in x is equal to v0t. Remember, v0t is just 65 meters per second. We have this. Remember, t at this moment is going to be 6. So now we can just plug everything in. So it will look like this. 65 times 6 plus 1/2 times 9.7 times 6 squared. Now, because we're trying to find, as I stated, basically this right here, this distance, then if we find this distance, and we're going to have basically, this is a long line from 0 to 6, and this is to 2, and then this to 6. So if we find the whole thing, the whole length, we minus the whole length by this little chunk here, we would just get this length, which is what we want. So that's why we will also find t is equal to 2. So basically I'll put it here, change in x. It's the same thing, except the 6's, we're going to replace this by 2's. And basically, if we look at this, this is the same thing as saying the change of x from 2 to 6. I'm just writing some sort of pseudo notation here. Is going to be equal the change in x from 0 to 6 to minus the change in x from 0 to 2. So let's do that. I'm going to write it right here. So what we're looking for, this right here, it's going to be equal to this guy minus this guy. So let me just solve this. 65 times 6. 65 times 6 plus 0.5 times 9.7 times 36, which is 6 squared, is 564.6. And for the other one, we need to replace the 2's. We get 149.4. So what would that be equal to? 564.6 minus this value is going to be 454 meters. And that, thanks very much.